All right, here we go. So we're finding the x, y intercepts for x minus 2 over x squared plus 3x minus 4, and we want to find the x intercepts. So how do we find the x intercepts? Set the numerator equal to 0. Correct. Oh, be quiet. All right. So I'm doing this as part of my 7th hour, 8th hour class. For those of you who are watching this, which probably won't be. Anyway, um, x minus 2 is set equal to 0, and we get x equals 2. All right. So how about our y-intercepts? Correct. We plug in 0 for x. So 0 minus 2, and then 0 plus 0 minus 4. So here we end up getting negative 2 over negative 4, which is then 1 half. Okay. So we have x equals 2 and y equals 1 half. So that's the x-intercept and the y-intercept. Okay? That's what it says, x equals 2. Plug in 0. So the x-intercept, you set the numerator equal to 0, the y-intercept, you plug in 0 for x. Okay, so for the second one, s of x, what do we have to do here before we can get started? We have to factor, right? So we're going to factor x squared minus 4x minus 5. So we factor that, we're going to get x minus 5 and x plus 1. So then for the x-intercepts, again, we set the numerator equal to 0, right? So x minus 5 equals 0, and we get x equals 5. X plus 1 equals 0, we're going to get x equals negative 1. And the y-intercepts, we go back to the original equation, and we plug in 0. So we're going to get 0 squared minus 4 times 0 minus 5, and 0 minus 3. All the x terms, all the x terms cancel out because those are our zeros, and we get negative 5 over negative 3, which is positive 5/3. So y equals 5/3. And that was x equal negative 1. Okay? Any questions on those? What do you mean? Right here? Oh, I'm sorry. Yeah, we have both those. My bad. All right. Next one down for horizontal and vertical asymptotes. So for horizontal asymptotes, what do we do? Horizontal, we look at the degree, exactly. So what is the degree on the numerator here? 1. So the degree here is 1. What's the degree on the bottom? 2. We have to take the exponent on both factors and add them together. So the degree is 2. So if we have the numerator, the degree of the numerator is smaller than the denominator, that's going to be y equals 0. Okay, so it's not just 0, it's not nothing, it's y equals 0. It's a line on the x-axis in that case. If the degrees were equal to each other, then we would look at the coefficients, leading coefficients. All right, so how about the vertical asymptote? Set the denominator equal to 0. So the denominator would be x minus 3 equal to 0 and x minus 4 equal to 0. So we end up getting x equals positive 3, and here we would end up getting x equals 4. Right? Okay, and then for the next one, r of x equals 3x squared over x squared plus 2x plus 5. If we try to factor the denominator, we won't be able to. And if we use the quadratic formula or quad 3 on the calculators, what you will end up with is negative 1 plus or minus 2i when you work it out. Okay? What does that mean? Any thoughts? Well, that's for the denominator, right? So when we look at the denominator, what are we looking at? Horizontal or vertical? Right. And can you graph an imaginary number? No. So therefore, there are no vertical asymptotes. So that's a none. So if you run into that situation where you have an imaginary number, then you can't assess that on a graph. So it's just none. But the horizontal asymptote, this is where the question was asked, what if we have an equal value of the degree? So here, our degrees are equal because they're both 2. So what do? Look at the leading coefficients. So the leading coefficients are the 3 over 1. So the horizontal asymptote is going to be 3. Okay? All right. Moving on to the next one. Here we have to put it all together. We have to get the x and y intercepts, the asymptotes, and then sketch the graph. So now we have x minus 2 over x squared minus 4. What's the very first thing we should always do when we're trying to do all this? Factor. Okay, so we want to factor. Is there anything to factor on the top? No, so we just keep x minus 2. How about factoring the denominator? X minus 2 and x plus 2. Because it's a difference of 2 squares, so a squared minus b squared factors out to be a plus b and a minus b. What do we notice here? Anything? They're all 2's. What else? Do we have any common factors? We have x minus 2 on the top and the bottom. So what happens is that cancels out. But we don't want to ignore it. We want to keep in mind that it was there in the first place. Okay? Because whenever you have something in a denominator with a variable, we know that there's times when you cannot equal those numbers, which is why we end up with vertical asymptotes, right? Does that make sense? If I had a negative 2 here, that would cause us to have a 0 in the denominator. And that's why it causes that vertical asymptote. Well, we have to consider the fact that positive 2 will also create a 0, because 2 squared minus 4, 2 squared is 4, and 4 minus 4 is 0. Okay, but in this case, it doesn't create a vertical asymptote because the factor got completely wiped out. But we do have to consider that in our graph, we know that x cannot equal 2, which we will look at when we start to graph. Okay, we cannot have x equal positive 2. So now, when we cancel out that factor, we have 1 over x plus 2. So that's our new function, and that's what we will use for the rest of this way on out. So for x-intercepts, we usually set the numerator equal to 0, but the numerator is just a number. So there's nothing we can do, therefore there are no x-intercepts. Okay, for the y-intercepts, we look at plugging in 0 for x. If we plug in 0, we get 1 over 0 plus 2. And that's going to give us 1/2. So our y-intercept is y equals 1/2. For our vertical asymptotes, so for the vertical asymptotes, we take and we set the denominator equal to 0, right? So x plus 2 is equal to 0. We're going to get x equal negative 2. So that's a vertical asymptote. We have to also consider the fact that from the factor that was canceled out, x cannot equal 2. And then our horizontal asymptote, what is the degree of the numerator? 0. If there's no x's, there's no degree. So the degree is 0. And what's the degree here? 1. Okay, so this is, the numerator is smaller than the denominator. So we're going to have y equals 0 for our horizontal asymptote. Okay, now because we know that there's a horizontal asymptote, we know that there's not a slant asymptote. If we notice that the numerator had a larger degree than the denominator, then we'd have to make sure to see if there's a slant asymptote. And you're going to have to just know that for the test. All right, so now let's go ahead and graph everything. We're going to go down here. Our y-intercept was 1/2. Our vertical asymptote was at -2. Yeah, I provided them. You don't have to use them, the boxes, on the test. All right, but they're there in case you want them. Our horizontal asymptote is y equals 0, so we're going to have a horizontal line there. Okay, I think we have everything labeled, except we need to consider and remember that x cannot equal 2. So somewhere around here for that x equal 2, we cannot have a solid dot. We have to put an open dot in our graph to represent no value. All right, so now we what do we do after we get all this stuff on the graph? Test points, right? And our test points come 0.1 units away from the vertical asymptote. So this vertical asymptote is at -2, so we're going to use what? -2.1 and -1.9. So the -2.1 is on the left, -1.9 is on the right. When we plug in, we're going to be using just the 1 over x plus 2. And what's the sign of the numerator? It's positive, right? It's not ever going to change. So positive. And how about if we plug in -2.1 for x plus 2, we're going to get negative. And a positive divided by a negative is equal to a negative. All right, so that means our y value is going to -infinity, which means the arrow will be going down. Okay? The arrow will be going down on the left-hand side of the graph. For -1.9, again, the numerator stays positive. When we plug in -1.9 plus 2, it's going to be positive. And 2 positives makes a positive, which positive infinity, exactly. So over here on the right-hand side of the graph, it's going to positive infinity. All right, so now on this particular problem, our horizontal asymptote is on the x-axis. We didn't have any x-intercepts, right? So therefore, we know our graph will not cross the x-axis, which means it will also not cross the horizontal asymptote. So we don't need to test those x values way to the left and way to the right, the -20 and +20, because we already know that we're not going to cross that line because it's also the same as the x-intercept. And if it was going to cross the line, we would have found that out up here when we did our x-intercepts. Make sense? All right. So since I'm already on the left-hand side of the vertical asymptote, I'm already below the horizontal asymptote, I'm going to stay under the horizontal asymptote. And then to the right of the vertical asymptote, I'm going to stay above because I'm starting above. So I go down through, okay, and then I'm going to level out along the horizontal asymptote. Now remember, I need that open dot here. So I need an open dot right there, and then I continue on with my graph. So then I'm going to move that part of it. Oh, geez. I'm going to just delete it. There we go. So you can see the graph has that open point. Because that was that x minus 2 factor that got canceled out completely up here when we had x minus 2. We have to know that that came from the denominator, and that means we can't equal 2. Okay? So that doesn't happen very often, but it does occasionally. So this particular graph, that's what it's going to look like. Okay, let's look at this. We have x squared plus 3x over x squared minus x minus 6. first thing we're going to do is factor. So we're going to have x times x plus 3, and the denominator will factor to be x minus 3 and x plus 2. Now I'm going to find my x-intercepts. That's when we have the numerator equal to 0, so that's x equal to 0, and x is going to give me, from the x plus 3, is going to be negative 3. The y-intercept, I will plug in 0, so that's 0 plus 0 in the numerator, and then at the bottom we're going to get 0 minus 6, which is 0 over negative 6, which is 0. So our y-intercept is at 0. Our vertical asymptote is the denominator values, or factors, set equal to 0, so we're going to get x equals 3. And then also x plus 2 equal to 0 will give us x equals negative 2. Our horizontal asymptote, our degrees are equal. So we look at our leading coefficients. Our leading coefficients are 1 and 1. So our horizontal asymptote is y equals 1. All right, so then we're going to go ahead and graph those. So the x-intercepts are 0 and negative 3. Our y-intercept is already on there at 0. Our vertical asymptotes are 3 and negative 2. 3 and negative 2. And our horizontal asymptote was y equals 1. So we've got 3 sections of our a graph here, right? So we're going to have 3 different graphs. Left and right of our x equal negative 2 asymptote will be negative 2.1 and then negative 1.9. Over here at x equals 3, we have 2.9 and 3.1. We're recording. So we have, up here we're going to put in negative 2.1, negative 1.9, 2.9, and 3.1. So then we're going to test our behavior. We're going to use x times x plus 3, and we're going to have x minus 3 times x plus 2. All right. So plugging in negative 2.1 in for x, it's going to give us what? Negative. Negative 2.1 plus 3, positive. Negative 2.1 minus 3, negative. And negative 2.1 plus 2, negative. 3 negatives is a negative. An odd number of negatives stays negative. So that is going to negative infinity. So on our graph, we are going to negative infinity on the left side of that asymptote, vertical asymptote. Okay, so for negative 1.9 for x, that's negative. Negative 1.9 plus 3, positive. Negative 1.9 minus 3, negative. Negative 1.9 plus 2, positive. Two negatives is going to make that positive. So that's going to positive infinity. So on the right-hand side of that vertical asymptote, we are going up. Now over to 2.9. 2.9 on its own as x is positive. 2.9 plus 3 is positive. 2.9 minus 3, negative. 2.9 plus 2, positive. 1 negative is going to stay negative. So that's going down to negative infinity over here at 2.9 on the left-hand side of that vertical asymptote. And then 3.1. 3.1 by itself will be positive. Plus 3 is positive. 3.1 minus 3 and plus 2. So all positive. So our outcome is positive, which goes to positive infinity. And we're going to graph up there. Okay, so now we look at our graph. And because the horizontal asymptote is not on the x-axis, we want to confirm whether we stay underneath or go across the horizontal asymptote to level out. So I'm going to choose a value like negative 20. I should have kept my equation down here. All right, so negative 20 times negative 20 plus 3, and then negative 20 minus 3, and negative 20 plus 2. Doesn't have to be, it just needs to be far away from your... Yeah, should be fine. So that's negative 20 times negative 17. And then we'll add down here, we're going to have negative 23 times negative 18. So when we do that, calculate that out, what do we get? So when we multiply these out, we're going to get 170 over 207, which is approximately 0.82, and 0.82 is less than 1, correct? 0.82 is less than 1, so it's going to stay underneath the horizontal asymptote. So when we come up through our x-intercept there, it's going to take a sharp turn and stay under the horizontal asymptote. So then, in the middle, we can see we've got two arrows. On the left side it's going up, on the right side it's going down. We have an x-intercept, so we don't need to do any testing of values in the middle. We can go ahead and draw our S-curve graph going through the middle. Because it's going, you already had the arrow on the left going up, and you had the arrow going down here, so you had to go through that point and go from top to bottom. Yes? If there was not an x-intercept there, there would be some calculation problem probably somewhere that I would check. All right, so now on the right-hand side of the graph, I'm going to make sure I stay above the horizontal asymptote, so I'm going to use a number like 20. So 20 times 20 plus 3 over 20 minus 3 times 20 plus 2. So that's 20 times 23, and that's 17 times 22, which is 1.29, so approximately 1.29, which is greater than 1, so we know that we're going to stay above the horizontal asymptote, and there's our graph for that. Yep, all that for a graph. Okay. This one, okay. For the first problem here, it just says find the slant asymptotes. We aren't graphing. All we're doing is finding the slant asymptote. We know there's a slant asymptote because the degree of the numerator is 1 larger than the denominator. So the degree on the top is 2. The degree on the bottom is 1. So 2 is only one value greater than 1. So we know that there's a slant asymptote there. And so that means we have to divide. We're going to do long division. You could for this particular one, yes. Down here you can't, because it's not set up to be synthetic division. Right. All right, so x minus 1 into x squared plus 2x plus 0. What do you, to multiply into x squared, I need an x. And then x times x minus 1 is going to be x squared minus x. I'm going to be subtracting, so my first terms cancel, and then 2x minus a negative x would be 2x plus x, which is 3x, right? I bring down the 0. To multiply x to get 3x, I need a 3, and that's going to give me 3x minus 3 down there, and whatever I get down there is my remainder, and I don't care about the remainder. All I care about is the x plus 3. And I get y equals x plus 3, and that's what's going to determine my slant asymptote. is that equation. So for that particular problem right there, that's all we needed to do. Long division. In this case, we could have used synthetic division because it is the type of binomial down there. The leading coefficient is 1. It is linear. So yes, you could do synthetic division. Down here for the next problem, we can't. We have to do long division. So let's look down here and let's work through this problem. Yes, y equals x plus 3. Now, well, yeah, we'll show what to do for a slant asymptote here. Okay. I cannot factor the numerator, so I'm going to leave it. The denominator is 2x minus 1 and x plus 1. Nope, I have that backwards. 2x plus 1 and x minus 1. No, I had it right the first time. Okay, I had it right. 2x times 1 is positive 2x, and then minus x is going to stay positive x. All right. So my x-intercepts is when the numerator is equal to 0, right? So I need to set x cubed plus 4 equal to 0. The only way to solve this is the regular solving of an equation. So I'm going to subtract the 4. I get x cubed equals negative 4. I have x cubed. I need x. I have to cube root this. So I'm going to cube root it. And you could do that with your calculator. And you get negative 1.59. So x is equal to negative 1.6 around. Okay? You can cube root a negative, but not square root. Right. My y-intercepts, I'm plugging in 0. I'm going to get 0 plus 4 over 0 plus 0 minus 1. All the zeros obviously are going to have no effect, and I get 4 over negative 1. So y equals negative 4. I'm going to clean this up a little bit here. Okay. My vertical asymptote, I'm taking, I had 2x. There we go. Okay, so my vertical asymptotes, I take each one of these, set equal to 0, each one of my factors from the denominator. So 2x minus 1 is going to give me x equals 1/2. And from x plus 1, I will get x equals negative 1. How about my horizontal asymptote? I look at the degrees. I notice that the numerator is larger than the denominator, which means I have no horizontal asymptote, which means I need to check for slant asymptote. The numerator is 1 larger than the denominator. So I'm going to divide. So I take 2x squared plus x minus 1, and I will divide into x cubed plus 0x squared plus 0x plus 4. I have to fill in those missing terms. So how do I get from 2x squared to x cubed? Well, I know I need an x. That will give me x cubed. But how do I get from 2 to 1? I need 1/2. So I put a 1/2 here. Okay, 1/2 x times 2x squared is x cubed. 1/2 x times x is 1/2 x. And 1/2 x times negative 1 is negative 1/2 x. I subtract these. My first terms will cancel. 0 minus 1/2 x is going to be negative 1/2 x. 0 minus a negative 1/2 x is, I'm sorry, that's squared. Yep. That's going to be positive 1/2 x, and then I bring down the 4. And what do I multiply to get from 2x squared to negative 1/2 x squared? 1/4, negative 1/4, right? So negative 1/4 and I'm going to get negative 1/2 x squared minus 1/4 x plus 1/4. And whatever I get down there is my remainder that I don't care about. All I care about is that quotient. So my slant asymptote is y equals 1/2 x minus 1/4. Okay? So I start plotting my points. So negative 1.6 is about right there. Y equals negative 4 is down here. I also have a vertical asymptote at x equals negative 1. And also at x equals positive 1/2. And I have a slant asymptote. All right, so I need to graph this. It's in slope-intercept form, so I'm going to start at my y-intercept of negative 1/4. So there's negative 1/4 right there. And now I'm going to apply my slope of 1/2. So when I'm in between values, integer values, and I have to count up 1 or apply a slope like rise over run, I have to be careful that, okay, I'm thinking I'm 1/4 units down below my grid. So when I go up 1 unit, I have to remain 1/4 unit down. So up 1 is going to be there, and then over to the right 2 units, that's there. I'm down 1/4 unit. So I have to stay consistent with that. So up 1 and over 2, right there. Up 1 over 2, right there. Same thing if I go down 1. I have to go down, make sure I'm a 4th unit down below that grid, and then over 2, down, left 2. So down 1, left 2, down 1, left 2. So now I have this, and that is my slant asymptote. Now I test my behavior. And I'm going to test negative 1.1, negative 0.9. That's at 0.5. 1/2 is 0.5. So 0.1 units to the left is 0.4, and 0.1 units to the right is 0.6. So those are the values that I will be testing. Let me clear this area out. So negative 1.1, negative 0.9, 0.4, and 0.6. To save time, I know that on the left for negative 1.1, I am positive, which will be positive infinity. For 0.9, I know that's going to be negative, which is negative infinity. For 0.4, it's negative, which is negative infinity. And 0.6 is positive for positive infinity. So on my graph, I'm up here. I'm down and down and up. When I'm graphing this, I have points here guiding me, my x-intercept there. So I'm going to come down through that, and then I'm just going to follow the slant asymptote. In the middle, I have a y-intercept there, and both my arrows are pointing down. So I just have to go up and go through that y-intercept and then come right back down, because my arrows both go down. And then over here to the right, I'm going to be staying above that horizontal asymptote. I could test if I need to, but that's what my graph is going to look like. And then we're done.